third law of motion. According to Newton's third law of motion, if an object exerts a force on another object, then the second object exerts some force on the first one, which is equal in magnitude but opposite in direction. These two opposing forces which acts on two objects are called as action-reaction pair. So Newton's third law explains what happens if an object exerts a force on another object. Now we can perform an activity to know the Newton's third law of motion. Pulling two spring balances. Take two spring balances and connect one end of the two spring balances. Now connect the second end of the first spring balance to a wall and push the second end of the second spring balance. If you observe the reading of spring balances, both the spring balances shows the same reading. That means the force exerted by first spring balance on the second one is equal to the force exerted by the second spring balance on the first one. If the two spring balances are considered as A and B, the force exerted by spring balance A on B, FAB, is equal to minus FBA. That means these two forces are equal in magnitude but opposite in direction. So here the force exerted by one spring balance on the other spring balance is called as action, and the force exerted by the second spring balance on the first one is called as reaction force. So from this action and reaction, both are equal in magnitude but opposite in direction. That means for every action there is an equal and opposite reaction, which is the statement of Newton's third law of motion. Let us observe some more examples for the Newton's third law of motion. If you observe a flying bird, the bird exerts some force on atmosphere with its wings. As the opposite reaction, atmosphere pushes the bird in upward direction. Here the force exerted by the bird on atmosphere is considered as action, and the force exerted by the atmosphere on bird is called as reaction. So here action and reaction are equal in magnitude but opposite in direction. In the same way, if you swim in a water, you push the water in backward direction, which is we consider as action. For this, water pushes us in forward direction, which we consider as reaction. Here also the force of action and reaction both are equal in magnitude and opposite in direction. If you observe the motion of a rocket expels gases from the jet with high speed. These gases exert high force on atmosphere. For this, atmosphere pushes the rocket in upward direction with more acceleration. Here the force exerted by the expelled gases are action, and the reaction is the expelled gases exerts on